if this is what you need to cover, most times teachers can only cover a part of what is needed. Unfortunately, because of the pandemic, that part is now even smaller. Than what was normal. So the purpose of we learning together we learn, the purpose of having this initiative is to help to supplement what your teacher is doing, even if we are able to add a little piece to it. Even a little piece to it, it will make a difference. So that is the objective, that is the understanding. If we could just add a little piece along with what your teacher does, then you're still a little better off than where you would be if there was no help. What does this mean? It means that some of the topics we will cover are very simple for you. But I promise you that if you stay with us long enough, you will find some topics that are a little different and a little bit more challenging. So I invite you to take this ride with us. I invite you to travel with us because it's going to be a fun time, very fun. It's not supposed to be stress, it's supposed to be help, okay? So then the question is, where do we start? And that's a good question. Where do we begin? And as I thought about where we could start, I said, well, I could start by telling you my name. My name is Desmond Dunkley. So I'll write it here so you can see. Desmond Okay? And I'm one of many people who care about you. I'm just one of many people who want to make a difference in your life. I am one of many people who just want to help in this time of need. So this was not my original idea because my style of teaching is to engage, to question, to participate, to get excited and all that stuff. But because of the limited situation and the wide cross section we're trying to cover, that is not possible at this time. So bear with us as we try to do a little something to help make a difference. So what I came up with as a starting point, which was, I must say, not my idea again, it was one of our lovely teachers, Ms. Dawn Dawes, who recommended that, why not start with some basics and then let it grow, let it evolve. And I said, excellent, excellent idea. So I decided that I'm going to start with something that gives a lot of students difficulty over the years of teaching. And I think I'm now at about my 25th year of teaching, no, 24th. This is my 24th year of teaching math. I've discovered that regardless of what age my students are, they still struggle with fractions. They still struggle with percentages. So I figure, hey, why not start with something like that? Maybe this might be a good start, getting to know you. It could be something that you're very good at, or you might be saying, yes, this is exactly what I needed. I don't know, but let's give it a try. But I promise you that we'll not always stay at this level. It will grow. There's gonna come a time when I come in and you ask yourself the question, who is this crazy man? Because what he's doing is just like way over here. Hopefully that doesn't happen often. But every now and again, I will challenge you. But for today, we're gonna have some fun, starting with fractions, decimals, and percentages. I'm not sure how much we'll cover today, but whatever we do not cover, we'll continue the next time around. So let's get started. For a long time, we have always needed to count. We need to keep track of what we have. You know, how many children we have, how many chickens, how many goats, how many horses, donkeys, cows, whatever. We need to count how many mangoes we have, count how many marbles we have. And for those little kids who are fortunate, they might want to count how many cars. And then later on, people start to compare numbers and say, how many of my cars are good and how many are bad? And that comparison started to take the form of numbers. They could say, okay, 5 are good and 10 are bad. And somebody said, oh, so what fraction of my cars is good? What fraction is good? Well, the question is, how many cars do I have? According to this, and we're talking about just toys. This is not real cars, these are just toys. You have 15 toys, and you want to see what fraction of your toys is good. You say, oh, there are 5 good out of a total of 15. So that's the fraction. So this was a way to start comparing the good with the total. Very simplistic, but you'd be surprised to know how this concept evolved and got bigger and bigger and bigger. For example, for the adults who might be tuning in, you might say to yourself, okay, I earn $800 per week, but I have to spend $100 on transportation, on traveling. And you say to yourself, what portion of my income am I spending on traveling? What fraction am I spending? And the answer would be 100 over 800. That's the comparison. And over, we start to see that this start to go into many, many different parts of our lives. So fractions, later on we discover that we can convert fractions to something called decimals. Interesting. So how do we go from fractions to decimal? Before we do that, I would say to you that we always compare a part with the whole or a part with the original. Keep that in mind. Keep that word original in mind. So we always want to compare with the whole, and the whole is often used as one. Just as though we are one, sometimes we don't behave like we are one, but in truth and fact, we are one humanity. And the moment we start realizing that we are all in this together, trust me, a lot of things will change. Let me say it again. The moment we start recognizing and accepting that we are together, we are one whole, it will make a difference. For now, let's stay with the fractions and decimals, but you will hear more about that later on. If, for example, you have a total of 8, and you take all of them, then you have 8 out of 8, and that's a total of 1. What do you mean by that? Okay, if you have a soccer squad, and there are 18 people on the squad, the coach might say, okay, what fraction of my players are present? Somebody might say, oh, 12 of them are present. So that's equal to 12 over 18. We will realize that the 12 over 18 can also be simplified. Again, that's taking fractions to another level. I know I've already lost some of you saying that this is too easy. This is too easy. I say, stay with me, because that will change eventually. So 12 out of 18 are present early, and then more came, and we realized that, that changed to 15 out of 18. More people came, 3 more people came, so now we have 15 over 18. If you look at this, this is a bigger fraction than this. This is smaller than that. But there are still 3 people missing. So when the other 3 arrive, how many people altogether do we have? What portion of the team is present? The answer is 18 over 18. And guess what? 18 divided by 18 is 1. So when all is together, we say that it's 1, it's a whole. So if it is not 1, if it is less than 1, it says that it's a part of. If it's less than 1, it's a part of the original. The whole is 1. Small fraction that's less than 1 means that you do not have a complete set. Okay? Now, I would like to take the time to let you know that fractions are very neat because they can be simplified. What do you mean by that? For instance, if you had, say, 20 out of 30, I'm saying to you that this fraction is the same as other fractions. For example, if I divide the top by 2 and I divide the bottom by 2, I end up with 10 over 15. Because I divided the top and the bottom by the same number, we actually end up with an equivalent fraction. They are the same value. They are the same. This looks bigger because we have bigger numbers, but in terms of value, they equate to the same. We could say, oh, but I can still reduce this further. This is called reducing the fraction or simplifying the fraction, making it smaller, making it simpler. So 10 over 15, I say, wait a minute. I could divide the top and the bottom by 5. 5 works perfectly. So I go 5 into 10 goes 2 times, 5 into 15 goes 3. So wait a minute. 20 over 30 is actually the same as 10 over 15, and that's actually the same as 2 over 3. Now, when I look at 2 over 3, I cannot go any further. There is no number apart from 1 that can go into both 2 and 3. So we say that it's completely simplified. That's the best you can do. What is the takeaway? What's the most important thing? We have what is called equivalent fractions. Just as how we came this way, we could have gone the other way, where instead of going smaller, we can go bigger, and yet it's the same fraction. For example, instead of dividing top and bottom, we could actually multiply top and bottom. If you multiply top and bottom by, say, 2, we end up with what? 40 over 60. Guess what? 40 over 60 is also the same as 20 over 30 and also 10 over 15. These concepts are very important as we progress. So what is important for you to recognize is that a fraction can be written in many different ways, but has the same value. That's the takeaway. Different ways or different forms, but same value. Okay? Good. Of course, from the get-go, instead of dividing by 2 and then dividing by 5, you could have looked at it and said, wait a minute, I could divide top and bottom by 10 straight from the start. 10 into 20 goes 2 times. 10 into 30 goes 3 times. So 20 over 30 is the same as 2 over 3. Very important. So, what happens when you start to combine fractions? What happens when you start to combine fractions? Interesting. For example, if I had, say, a half, and I want to add to it 2/3. A half plus 2/3. Suppose I want to combine those two numbers. I'll say, wait a minute. Interesting. But let's pause for a second. Let's pause a little bit and let's go and do a sidebar. Let's check something out. If we had, say, 1 over 8 plus 3 over 8. This is 1 over 8 plus 3 over 8. In math world, we say these are the same denominators, the same bottom. The bottoms are the same size. When that happens and we're adding or subtracting, then we just go ahead and just do the addition just like that. So the bottom doesn't change, and it's 1/8 plus 3/8 gives us 4/8. And of course, those of you who are watching know that 4 over 8 is also the same as 1 over 2 if I divide the top and the bottom by 4. Okay? So this works out beautifully. We didn't have to do anything except just combine the top. And the top is called, these are called the numerators. Top is numerator, bottom is denominator. Okay? Top is numerator, bottom is denominator. And so we end up with a half. Look at this. When we look at this, we notice that the bottoms are different. This is 2, this is 3. So in order for us to combine them through addition or through subtraction, they must have the same denominator. If the denominators are different, you can't do them just like that. You have to make some changes first. So let's try and see what happens. When I look at the numbers 2 and 3, I say to myself, what happens if I change the denominators so that the two bottoms are the same? What is the best number I could use so that both 2 and 3 can go into that number? And if you think long enough, you would think of the number 6. 2 can go into 6, 3 can go into 6. So I need to convert this so that the bottom is 6. And if I change the bottom to 6, I have to change the top in the same proportion. So what must I do to 2 to get it to 6? I say, if I multiply the bottom by 3, I get 6. If I multiply the top by 3, I get 3. 3 times 1 is 3. So what I'm saying to us is that 3 over 6 is the same as 1 over 2. Let's check. Suppose I divide by 3, I get 1. If I divide by 3, I get 2. So these are similar fractions. They are equivalent fractions. So then we come to the other one. What must I do to the bottom to make it to 6? If I multiply top and bottom by 2, then that makes this 6 and also makes this to become 4. Now we have the same denominator. We say, yes, now we can add because the denominators are the same. So we end up with 6, 3 plus 4 is 7. Now, watch this carefully. In this example, the 7 is bigger than the 6. So we refer to this as whenever the top is bigger than the bottom, whenever the numerator is bigger than the denominator, we call it an improper. Improper fraction. It doesn't mean that they're rude or out of order. It just means that the top is bigger than the bottom. That's all it means. And in some cases, it's a good thing. Okay, so don't think improper means bad in this case. However, I should hasten to say to you that 7 over 6 can also be written as a mixed number because 7 over 6 is the same as 6 over 6 plus 1 over 6. It's a whole plus 1/6. It's one whole because 6 over 6 is 1. So I can actually write this, as I move my camera down a little, I can write this as 1 and 1/6. So what have I just done? I've just changed my improper fraction into a mixed number, a whole number, and a fraction, a proper fraction. So that just came in just like by the way, okay? Let's try doing a subtraction. Let's try doing a subtraction. I hope I haven't lost anybody yet. I hope you haven't gone away and say, oh, this is boring, this is too easy. I encourage you to stay with me. Stay with me a little longer, okay? So let's try something like a subtraction. If we had, say, 5 over 8, take away 2 over Oh, that's not a good idea. That's not a good idea. Let's say take away 1 over 3. Let's do that for now. So we ask ourselves the question, what number can both 8 and 3 go into without a remainder, and the best number that comes up is 24. 24 is the best number. So I could change 8 to 24 by multiplying this by 3. 3 times 8, 24. 3 times 5, 15. And we're going to minus. Now I need to change 3 to 24. In this case, if I multiply this by 8, I get 24. I multiply the top by 8, I also get an equivalent fraction. So it's 8 over 24. And now we have the same denominator. Now we can subtract. And what do we end up with? 7 over 24. And that will be our answer. So you could say then, oh, that's very, very easy. What happens if we end up with crazy numbers like this, for example? Suppose we ended up with, say, 2 1/4 minus 1 2/3. How about that? Two mixed numbers and doing subtraction. Now that's crazy. Okay? What is that? What is the recommendation with stuff like this? Maybe it's a good idea to put everything as improper fractions. Put this as an improper fraction, put that as an improper fraction. That might help. But also, you could also subtract the whole numbers. 2 take away 1 is 1. So really we have 1 1/4 take away 2/3. But that I might lose somebody like that. So what we'll do, just to keep it simple, not the only way, good thing to remember with math is that oftentimes there are many ways to do the same thing. There are different ways to end up in the same spot. Just for now, keeping it very simple, I'm going to make it into an improper fraction and then work with it from there. So 2 1/4 as an improper fraction is going to be 4 times 2 is 8 plus 1 gives me 9 over 4. Minus 3 times 1 is 3 plus 2 is 5 over 3. So this is equal to that. I've rewritten 2 1/4 and I've rewritten 1 2/3, and now we have a subtraction. So now we have a common denominator that we need to create so that we can do the subtraction. I look at 4 and 3, and so happen that 12 will be my best number to use as my denominator. So this would be, to get this to 12, I need to multiply by 3. 3 4s, 12. 3 9s, 27. Minus, to get this to 12, I need to multiply by 4. 4 3s, 12. 4 5s, 20. So now we have the same denominator. Now we can subtract. 27 take away 20 gives me 7 over 12. Guess what? That's our answer. That's our answer. Okay, so the camera needs to go down to get my 7 over 12. There it is, 7 over 12. Okay, so we have done addition of fractions and we have done subtraction of fractions. So what happens if you need to multiply fractions? Suppose you were asked to say, for example, find 2/3 times 3/4. How do we multiply fractions? I have good news for you. Multiplying fractions is not very complicated. It's actually easier than adding and subtraction. Because when multiplying fractions, all you have to do is multiply the numerators, multiply the denominators. When you get very sophisticated, you can actually see that if you have the same numbers on top and on the bottom, they cancel each other. But just in case you didn't see that, you will be able to take account of that later on. So pretend that you didn't see that. This would become 2 times 3 is 6 over 3 times 4, 12. But then you're going to say to me that, wait a minute, I can reduce this by dividing top and bottom by 6. And what do I get? 6 into 6 is 1. 6 into 12 is 2. So I end up with a half. Suppose I cancel these two What did I end up with? I'm glad you asked. Let's check it out. I'm going to make a space right here and check it out. So if I say 2 over 3 times 3 over 4, this is on the bottom, this is on the top, they cancel. So now we end up with 2 over 4. What is 2 over 4? Divide the top and bottom by 2, we end up with 1 over 2. And if you look, the two answers are identical. Identical. Different method, same answer. Two different methods, same answer. Okay? Now, yes, I gave you a very easy one. Suppose now, instead of having proper fractions, suppose I gave you something that is ugly. Like suppose I asked you to multiply 1 2/3 times 3 1/2. What will that be equal to? Now, that's very ugly. That's actually very ugly. So how do we go about doing this? Well, my recommendation to do this is make these two into improper fractions, multiply the numerators, multiply the denominators, and see what happens from there. And that will be your answer. So in this case, it's going to be equal to 3 times 1 is 3, plus 2 is 5 over 3. In other words, 1 2/3 is the same as 5 over 3. And it's 5 over 3 times 3 1/2 is going to be the same as 2 times 3, 6 plus 1, 7 over 2. So now we have two fractions. Of course, they are improper, but they are easier to work with than two mixed numbers. When multiplying mixed numbers, change them to improper fractions and let it roll. So now what do? To multiply these two, we multiply the numerators, we multiply the denominators. So 5 times 7 is 35, 3 times 2 is 6. So now we get 35 over 6, and we already discussed that if the numerator is bigger than the denominator, we call it an improper fraction. So you might want to write this as whole number, a whole number and a fraction, whatever is left over as fraction. So with this, 6 into 35 goes 5 times. So it's actually 5 with 5 left over, so it's 5 and 5, 6. That will be the conversion. Look at it again. 6 into 35, it goes into 30 5 times. But from 30 to 35, there are 5 left over. And that's what that is. 5 and 5, 6. Let's do one more, and then we'll move on. One more like this. Okay, let's try another one. This one, let's go with, okay, 2 3/5 multiplied by 4 2/3. Why not? Why not? Yes, let's see what happens here. These are two mixed numbers. 2 3/5, 4 2/3. What is the process? The process that I recommend is convert this to an improper fraction, convert that to an improper fraction, and then do your multiplication, and if possible, simplify. So, how do you make this into an improper fraction? 5 times 2, 10, plus 3, 13 over 5, times 3 times 4, 12, plus 2, 14 over 3. And now we end up with, this is a bigger number. 3 times 5 is 15. And to do this, we say 4 times 13, 4 2s, 12, 4 1 4 plus. So it's 182 over 15. Can that be reduced? Can that be reduced? There's no number that can go into top and bottom without a remainder, so we can't reduce it. However, we can write it as an improper, sorry, as a mixed number. 15 into 18 goes once, Remainder 3. 15 into 32 goes twice. Remainder 2. So it's 12 and 2, 15. And that would be your answer for that question. So we have added fractions, we have subtracted fractions, and we have multiplied fractions. So I guess the only thing that's left is how to divide fractions, and then we'll move into decimals, etc. So let's do a little division. What happens if we ask, what is 3 over 4 divided by 2? What is a half of, well, not a half of 2 over 4. How do you divide 3 over 4 by a half? Well, the rule is very strict. If you know how to multiply fractions, then the easy way to do this is to change this into a multiplication. What do you mean? Well, the rule says when you're dividing by a fraction, you flip the fraction and multiply. In other words, it's 3 over 4 multiplied by, when you flip this, it becomes 2 over 1. That is the rule for dividing fractions. You'll be shocked to know that there are people going to college who forget this. I've seen it happen over again. So don't laugh at me. I see it happen all the time. So I'm taking the time to remind us, because by January, when we're doing other stuff, I don't want you to be struggling with fractions, because I already did fractions with you. Got it? I'm smart. I'm doing these things now. So when I'm doing more stuff later, I can say to you, but I did that already. So therefore, you need to go to that video and look at it again, so that you're on board. Yes. And what does this become? Well, this can become, I mentioned to you that when you see something here and something there, you could simplify this. But not everybody is ready for that yet, so I'm going to go simple, but I'm also going to show you the other way to do it. 2 times 3, 6. 4 times 1, 4. So it's 6 over 4, and that can be reduced further to what? If I divide the top and bottom by 2, I end up with 3 over 2. The top is bigger than the bottom, so we call that an improper fraction. So I can reduce that to 1.5. 2 into 3 goes 1, 1 left over, 1.5. 1.5. So I mentioned, I hinted that I could have done this another way. What's the other way? From here, I had 3 over 4 times 2 over 1. I said to you that there's a 2 right here. I could divide the top by 2, that's 1. Divide the bottom by 2, that's 2. 3 times 1, 3. 2 times 1, 2. There is the same answer, 3 over 2. 3 over 2. There are so many different ways that we can do the same thing. And that's one of the beautiful things about mathematics. Okay? So we have just divided one that is not so complicated. Let's try and do another one that's ugly. Let's try and do one that's ugly. Say, for example, if I gave you 2 and 2/3 divided by 3/4. That's ugly. I think that's ugly. 2 and 2/3 divided by 3/4. How do we approach that? My recommendation, change this to an improper fraction. And then when you're dividing by a fraction, you change the division to a multiplication and flip the fraction. So what do we end up with? 3 times 2, 6 plus 2. This is 8 over 3. Multiplied by, we're going to flip this from 3 over 4, we flip it to 4 over 3. And what do we end up with here? As far as I can see, there's nothing you can simplify, so we are stuck. You just have to go multiply 8 times 4, that's 32. 3 times 3, that's 9. So it's 32 over 9. We call that an improper fraction, so we can actually reduce it or change it into a mixed number. What is the mixed equivalent? Well, we said 9 into 32 goes 3 times. 9 3 is 27, so we are left over with 5. So 3 and 5, 9. So that will be your final answer, 3 and 5 ninths. So far, so good? Excellent. So now I've done quite a few things with fractions. Let's shift gear for a little bit, okay? How do we go from fractions to decimals? Interesting. How do we go from fractions to decimal? For example, a half is equal to what decimal? Good question. How do you do that? Well, the way that I recommend that you do that is 1 divided by 2. Notice it's 1 divided by 2. You say 2 into 1, you can't. So you put a 0 and a decimal point and add a 0 right here. 2 into 10 goes 5 times. And there's nothing left over. So we realize that a half is the same as 0.5. All we did was we divided the top by the bottom. Let's try another one. Another common number we know is a quarter. What is that equal to? So we just discovered that a half is the same as 0.5. Very good. So again, with a quarter, it's 1 divided by 4. 4 into 1, you can't. You put a 0, and you bring down, you put a point and you bring down a 0. 4 into 10 goes twice. 2 4s 8. Subtract. 10 take away 8, leave 2. Add a 0. 4 into 20 goes 5 times. 5 times 4, 20. No remainder, so we end up with 0.25. So a quarter is the same as 0.25. What did I do? All I did was divide the top by the bottom. Let's try another one. How about 3/4? Again, it's 3 divided by 4. 4 into 3, we can't. Add a 0. 4 into 30 goes 7 times. 7 times 4 is 28. Subtract. We end up with a 2. Add a 0. 4 into 20 goes 5 times. 5 times 4, 20. Remainder 0. So we just discovered that 3/4 is the same as 0.75. So whenever somebody says that they want 3/4, and then somebody says they want 0.75, they're asking for the same thing. Just as if somebody says they want half dozen, and one person says they want 6, they're saying the same thing, okay? So 3/4 or 3/4 is the same as 0.75. So this is getting interesting. Let's try something else. Suppose I gave you improper fraction. For example, if I gave you, say 5/2. Or if I ask you, what is 2 and 1? Okay, let's use 2 and 1/5. 2 and 1/5. I ask, what is 2 and 1/5 as a decimal? You could say, oh, okay, so that's equal to 5, 2 is 10, plus 1 is 11/5. So that's what it is as an improper fraction. And now I need to divide 11 by 5. So 11 divided by 5, 5 into 11 goes 2 times. 2 times 5, 10. Subtract 1. 5 into 1, we can't. So we put our decimal point, add a 0. 5 into 10 goes 2 times. 2 times 5 is 10. Remainder of 0. So we discover that 2 and 1/5 is the same as 11/5, and as a decimal, it's 2 0.2. Let's do another one. Let's do another one. Let's try something a little bit more interesting. So 3 3/4. Or, okay, let's do that. So that's going to be equal to 4 3s 12. Oh, by the way, you already know that 3/4 is 0.75. So 3 is a whole number, so you could actually write it as 3.75. Ah, look at that. I wonder if that's correct. Let's check it out and see if it's correct. 4 3s 12 plus 3 is actually 15/4. Is this the same as that? Let's find out. So it's actually 15 divided by 4. 4 into 15 goes 3 times. 3 times 4 is 12. Subtract. We end up with 3. 4 into 3 we can't, so we put our decimal point. Add a 0. 4 into 30 goes 7 times. 7 times 4, 28. Subtract 28 from 30, we're left with 2. Add a 0. 4 into 20 goes 5 times. 5 times 4, 20. Remainder is 0. Remainder is 0. There it is. So 4 into 15 goes 3.75. We already know 3 3/4. The 3 is a whole. The 3/4 is a fraction. We already did 3/4 is the same as 0.75, 3.75, and we got the same answer going this way. So what have we just done? We have just learned how to convert fractions to decimals. Fractions to decimal. So now we need to ask ourselves the question, suppose we wanted to go in the opposite direction. How do we do that? The opposite direction. In other words, if I give you a decimal and I ask you what is the fraction that is equivalent, how do I do it? Very interesting. So convert 0.5 to a fraction. Here you go. This is what you do. For every position after the decimal point, you divide by 10, by 10. So for example, 0.5 becomes 5/10. For every number that comes after the decimal point, you remove the decimal point and put 1 followed by the number of zeros equivalent to the number of positions you move the decimal point. So 5/10 is equivalent to what? 5/10 divided top and bottom by 5 is a half. You know that a half is the same as 0.5. Let's do another one. Suppose I gave you 0.125. How many numbers after the decimal point? 1, 2, 3. So I'm going to write this as 125 over, remember what I said? We're going to divide by 1 followed by the number of zeros equivalent to the number of positions you move. 1, 2, 3. So it's going to be 1, 0, 0, 0. 3 zeros. 3 zeros. So it's 125 divided by 1,000. And now you try and reduce this. You can reduce it little by little, divide top and bottom by 5, etc., etc. But I'm going to go crazy and I'm going to divide top and bottom by 25. 25 into 125 is 5 times. 25 into 100 is 4. 25 into 0 is 0. So it's 5/40, which happens to be equal to 1/8. Whatever method you want to use, go step by step, you will end up with 1/8. Very easy, isn't it? Okay, let's try another one. Okay, let's try another one. If I gave you 2 and 2.35, and I asked you to convert that to a fraction. First thing first, you should notice that it's 2 wholes plus a fractional portion. 2 wholes plus a part. So it's going to be 235 over, how many positions did I move the decimal point to get rid of it? I'm moving it 1, 2 places. 1, 2 places. I'm going to put 1 followed by 2 zeros. Remember, it's 1 0 for every position you move the decimal point. Got it? So now it's 235 over 100. And like any good math student, you say, I'm not going to leave this just like that. I'm going to reduce it as much as possible. And I look at it and say, wait a minute. I could divide the top by 5 and also the bottom by 5. So how do I do that? 5 into 23 goes 4 times. 5 into 35 goes 7. 5 into 100 goes 20. So now I see that I get 47 over 20. Well, 47 is a prime number. It can't be divided by any number except 1 and itself. So this cannot be reduced any further. So you could leave it as an improper fraction, or you could write it as a mixed number, and we are all experts at that. 20 to 47 goes 2 times. 2 times 20 is 40, so there's a 7 left over. So it's 2 and 7 20th. So now what have we done? We have let's do another one. Let's do another one that's different. Let's do another one that's different. If I gave you something ugly, 0.864. Yeah, 0.0864, convert that to a fraction. Well, we will rewrite this as 864. That leading 0 doesn't have a value over here because that put 0.864 is the same as 864 over 1. Now, how many positions did I move my decimal point? 1, 2, 3, 4 positions. So I need to put 4 zeros. And now I need to reduce. When I look at this, I said, wait a minute. I could divide top and bottom by 4. So what do I get? 4 into 8 goes 2 times. 4 into 6 goes once. 4 into 24 goes 6 times. 4 into 100 is 4. 2 zeros. I look at this again and I say, wait a minute. I think I could divide top and bottom by 8. 8 into 21 goes 2 times. 8 into 56 goes 7. 8 into 40 goes 5. 8 into 0 goes 0. So now I have 27 over 50, and I think that's the best we can do. So this ugly thing here is the same as 20. Wait a minute, what did I do wrong? I think I did something wrong. Let's try one more time. Let's try one more time. 1, 2, 3, 4. 1, 2, 3, 4. 8, 6, 4. Let's go. 4 into this goes 2. 4 into 6 goes 1. 4 into 24 goes 6. And then we go 4 into this. Made a mistake. This shouldn't be 4, this should be 25. 4 into 100 is 25. 25, got it. I knew it was 2, it looked too unusual. So now we're ready to try again. What can go into 8 to 16? Can we use 8? Let's try. 8 into this goes that. No, 8 will not do. Let's go with 4. 4 into the top goes 5, 0, 4. What? 5, 4. There you go. 4 into 20 goes 5. 4 into 16 goes 4 times. 4 into 24 goes 6. 4 into 10 goes twice. 4 into 20 goes 5. 54 over 625 looks much better than what I had before. So there it is right there. Okay? So now we have converted from decimal to fractions and from fractions to decimal. So now I need to enter into percentages. And I already noticed that we'll have to continue this lesson on Thursday. But we'll continue from here. Let's start it. So what did I say the whole is equal to? We said that the whole is equal to 1. when dealing with fraction. For example, if you have 4 over 4, it's equal to 1. It's equal to 10 out of 10. You get complete, it's 1. Well, mathematicians came up with this concept of using a measurement out of 100 to explain how you have a part of. So the whole, instead of using 1, we say 100% is equal to 1. So 100% is the decimal equivalent to a whole. So if I came and I saw the mangoes, and you said, I'm going to give you 100% of the mangoes, it means that you're giving me all of the mangoes. Now, 100, if 100 is all, then 50% should be a half of what you have. So check it out. 100% is all, so 50% is a half of 100. So therefore, 50% is a half of what you have. So here we go. We use 100% to represent the whole. And then we use parts of 100 to express a part of the whole. That's basically what it is. So just as our decimals are used to represent a part of, like I say, a 0.5 is a half. And a half is the same as 50%. So 0.5 equal to 50% equal to a half. Okay? So as a decimal, 0.5. As a fraction, a half. As a percent, it's 50%. That's what it is. Okay? So let's go do some conversion. What is 40% to a fraction? To change a percent to a fraction, it's always the percent over 100. That's it. It is 40 over 100. And you simplify where you can. What is it? Well, the 0 here cancel this. Now you have 4 over 10, which happens to be the same as 2/5. So therefore, 40% is the same as 2/5. And of course, we can convert 2/5 to a decimal. We know that is equal to 0.40. We already learned how to convert a fraction to a decimal. So 40% is the same as 2/5, is the same as 0.40. Let's try another one. Suppose I gave you 75%. What is that as a fraction? Well, it's equal to 75. You always put it over 100. To change a percent to a fraction, just the same as 3/4. And we already agreed that 3/4 is the same as 0.75. We already worked this out before. Now suppose you ask me, how do you convert from a percent straight to a decimal? I will say to you, I'm so glad you asked. Look at this. So if I gave you 12.5%, what is that as a decimal? The way you do that is you put it equal to whatever you had before divided by 100. But instead of reducing it, when you divide by 100, you actually move the decimal point to the left. So the number of zeros tells the number of places to move it. So in this case, you're moving the decimal point 2 places to the left. So now you have 0.125. Notice what you had before, 12.5. When you move it 2 places, it's 0.125. And it's good practice in math to have a leading 0. If there's no number in front of the decimal point, put a 0, 0.125. Let's try another one. So if I gave you 8.5 And I ask you, what is that as a decimal? Well, we know that 8.5 is the same as 8.5%. 8.5 is the same as 8.5. I didn't do anything, I just changed it half to 0.5. To change the percent to a decimal, it's going to be 8.5 divided by 100. And when you do that, you're moving the decimal point 2 places. There is nothing here, so you're going to have to put a placeholder. There's going to be 0.085. And I recommend that if there's no number in front of the decimal point, put a leading 0 to make it clear that you didn't leave out something. So it's 0.085. Okay? Let's try another one. Let's try another one. Let's try another one. If I gave you, say, 22 and 3/5 of a percent, 22 and 3/5 of a percent, and I had to change that to a decimal. Well, you could change 3/5 to a decimal by itself. So it's actually 22 point. And when you do 3 divided by 5, you get 0.6. So it's 2.6%. And now you want to change that to a decimal. How do we change it to a decimal? Just put the number over 100, always over 100. So it's 22.6 over 100. How do you divide by 100? You move the decimal point 2 places, 1, 2. So therefore, your final answer is going to be 0.226. And of course, I recommend you put the lead 0. Okay? Another one. If 100% is 1 whole, then what is 130%? If 100% is 1 whole, 130% has to be bigger than 1 whole. Okay? So that's interesting. When does that come into play? Well, let's see. Suppose, for example, my friend Troy is earning, say, for example, $10,000. And I said that I'm not going to work for $10,000. I want to work for 130% of this. Then it means that if it's 130% of this, this is equal to 100%. So 130% is going to be a number that's bigger than 10,000. See, this is 100%. The original is 100. The new amount is 130. So since this is bigger than 100, your answer has to be bigger than 10,000. That's where the larger numbers come into play. Okay? Anyway, how do you convert that to a decimal? Nothing different. You divide by 100. So it's 130 divided by 100. And what do you notice here? Well, this 0 cancels that 0. So it's 13 divided by 10. We move this one, that's 0, so we move the decimal point 1 place. So it's 1.3. So 130% is the same as 1.3. And we'll do the last one. Last one. If I gave you 120.6%. Now I ask you, what is that as a decimal? Well, it's going to be the same as 120.6 over 100. And for this 2 zeros, we move the decimal point 2 places. So now it's equal to 1.206. Come Thursday, we'll see how these decimals become effective when you're trying to find a percent of a number. So what have we done today? We have danced around with fractions, we have messed around with decimals, and we have just started to touch percentages. I think this was a little start, just laying some foundation, And as I promise you, it will not always stay at this level. I'm just laying some foundation so we can take the building upwards. On behalf of the sponsoring foundations that have taken the effort to put this together, I thank you for spending this time with us. And I want to share with you a little project that I've created for you. I've created 2 assignments. 2 assignments. You will not be able to do everything now, but you could test yourself to see what you know. So I'm going to put them on the board for you right away. 2 assignments. Okay. Go to quizzes.com. And it will ask you for the quizzes code. The first code is 327-957-48. And the second code is 069-74-564. Okay? These codes will never disappear because I just went out and bought, just for you, I bought an extended, this is a free software, quizzes.com. But in order for me to avoid having deadlines on these assignments, I had to pay for a subscription. So I went out and did it for you. So now these codes will be there for a long time for you to get the practice that you want, a long time, indefinitely. However, if they're not accessed, then they will go away. If they're not accessed for 6 months. So this is actually 25 questions. And this is 60 questions. So you could take these for your warm-up, and after Thursday, when I've done the other portion of percentages, then you'll be able to knock this out. So you're gonna have some questions here that I haven't touched yet on percentages, but everything to do with fractions, decimals, and introduction to percentages you can do. But there are some other questions you can do. The good thing about these, you can do these quizzes over and over and over again. Unlimited attempts. There's no timing, and there's no limit as to how many times you can take it. Okay? I'm glad to have you, and I look forward to seeing you again on Thursday. Have a good evening.